right, we're going to start with a review of simplifying radicals. This is something that you would have done in Algebra 2, which is why I'm just doing a quick review over this topic. And this will get us going in our new unit. So first thing you're going to do is you're going to make like a little factor tree, which basically just you start with what times what equals 75, and there's obviously more than one answer. So just write the first thing that comes to mind. For me, the first thing that comes to mind is 3 times 25. And you're going to continue to factor this down until you end up with a prime number. And 3 is a prime number, so we would stop there because 3 doesn't divide into anything except for 3 and 1. So we'll just leave it as a 3. 25, however, does break down to 5 times 5. 5 is a prime number because the only thing you can divide 5 by is 1 in itself, so it's prime as well. Once you get to the end and you have all prime numbers, what you're looking for when you're doing a square root is you're looking for 2 factors that are the same. So like 5 and 5 are matching. So when you take the square root, basically this is like saying the square root of 25, which is equal to 5. So we would put 5 on the outside of the radical. So if you see a match, you bring that number to the outside of the radical. Anywhere where you don't have a match, so like 3, there's no other 3s, there's just one of them, that would have to remain in the radical because there is no square root for just 3. So 5 radical 3 would be the simplified answer here. Let's try that again. So for 48, we're going to again, just start with what do we think of, like what times what equals 48. So 6 times 8 was the first thing that came to mind. And you're going to continue to break that down until you get prime numbers. So 2 times 3 is 6. I would stop here because both 2 and 3 are prime. And then for 8, 2 times 4. 2 is prime, 4 is not because 4 is equal to 2 times 2. So we can take that one step further. Now you're going to look at the end of your factor branches, so 2, 2, 2, 3, 2, and we're looking for pairs. For square roots, we look for 2 things that are alike. So I have a 2 and a 2, so there's one match. And remember, when you find a match, you bring it to the outside of your radical. But this time I have another match. So I'm going to have 2 2s on the outside of my radical. And whenever this happens, you just multiply those 2 things together. And then anything that doesn't have a match will stay inside the radical. So we would have 2 times 2, which is 4. Square root of 3 would be your answer. Cube roots, fifth roots, if this little number up here is different or appears, that means that you're looking for a different number of matches. Let me show you what I mean. So I'm going to start with what times what equals 160, and 10 times 16 was the first thing that came to mind. Keep going and breaking this down. So 10 is 2 times 5. 16 is 2 times 8. And I'm going to keep going until I can't divide anymore. So this should do it. Now, because I have a cube root, the only way I can take something outside of this radical and simplify it is if I have 3 of the same thing. So like last time we were looking for a match or a pair. Now I'm looking for 3 of the same number, and I have 3 2s, so I can take a 2 outside of the radical, and I don't have 3 of anything else. So I'm going to take all the extra things, these extra things that don't have a match, and I'm going to put them back inside of a cube root. So there was a 2, and a 5. And remember, when you're putting more than one thing together, you would just simply multiply those all back together. So 2 times 2 times 5 would actually be 20. So my answer is 2 cube root of 20. All right, one more. This is a fifth root. So when I do my factor tree, I am looking for 5 of the same thing. So I need 5 of the same number to be able to break this thing down. And again, I'm just making my little factor tree, thinking of what times what equals each of these numbers. And you're looking at all the numbers at the very end. So 2, 2, 2, 2, 2, 2, and 2. Those are all the ends of my branches. And I need 5 of the same thing to be able to remove it from the radical. So 1, 2, 3, 4, there's 5. So I have 5 2's, so I can remove a 2 from the radical. And then what's left are these 2 guys here at the end. And remember that you multiply anything that's going to be kind of in the same location, in this case inside of the radical itself. And this means I'm going to have a 4 inside of my 5th root. So my answer is 2 5th root of 4.